Hi, my name is Caroline Green, and today I will be talking about the synthesis and reaction of the Grignard reagent. So I have my reaction set up here. So first what we're going to be doing is taking our bromobenzene as well as our magnesium and diethyl ether, and this will lead us to our Grignard reagent, which is phenylmagnesium bromide. And this will become our carbanion, which is basic and nucleophilic, so it's sensitive to protonation. Our carbanion will then attack this carbonyl carbon of the ketone, and it's through attraction of difference in charges. So as you can see here, one of these double bonds is going to be going up into the oxygen. So when that happens, obviously oxygen, we're only wanting two bonds, two lone pairs. So when you introduce another lone pair, then you're going to have a negative charge. So these two will be attracted to each other. So then this forms our alkoxide ion. So then after that, you're going to be using the ether, and this is where we will end with our product. So we're going to reprotonate the alkoxide ion, and this will leave us with our product, which is going to be the triphenylmethane. And so that is the reaction. I'm quickly going to go over some health precautions. So first, diethyl ether is flammable, so do not use it around any open flames. Haloalkanes should be used with gloves, which brings us to propanol, which also should be used wearing gloves. It has a noxious smell and should also be used in a fume hood. Beware of any pressure buildup when you are adding the sodium bicarbonate when you're trying to aid in the neutralization of the acid. You should never have a closed top on that when you're adding that, so just beware. And then I'm going to go over some reaction precautions. So the reaction should occur within 1 to 2 minutes. If you don't see that cloudy effect of the reaction, it could be an indicator that things haven't reacted yet. You can speed up this process by doing one of these things. Warm gently with a heating mantle, agitate by stirring, crush the magnesium to expose the surface. Beware not to injure any of the glass, so do this gently. And if it doesn't start the reaction, then you can also add some iodine, which reacts with the magnesium surface. But again, do all of these things with your professor. So every part of the apparatus is going to have to be heated for a few minutes, not too long, not too short, and the heat causes those traces of H2O, which are bonded to the surface of the glass, to evaporate. If you have extra H2O anywhere, you could throw off the entire reaction. Beware of any frothing. This could be an indicator of the death of the product. Beware of changes in color. These are going to be markers through the reaction to let you know where you are. If you don't have that brown color initially leave, then you might have some leftover H2O. And then when you add magnesium, it could become opalescent. So just beware, of color changes. For a higher yield of the Grignard reagent, you can add more bromobenzene, and we can have byproducts, which are biphenyl, which is caused by one electron transfer. And in order to counteract the product loss by this biphenyl, we can add more bromobenzene. I am 20 seconds over, but I hope you've stuck around for the rest of this, so I appreciate you listening. Thank you so much.